Hi everybody, I hope you're all doing well. So we've been focusing on lines, obviously, for about ever. So now we're going to actually start talking about what's called linear regression. And this actually goes back to us collecting data. So if I wanted to collect a bunch of data and determine how it relates with each other, determine an event with an outcome, how's it going to relate, I use what's called linear regression. And linear regression is really helpful because it helps to develop patterns in those given situations, but it also helps you be able to make predictions against all of your data that you collect. And that's what's called linear regression. And if you go ahead and you highlight your title for me, please. And then I want you to come down and highlight the border of this box down here. Linear regression is really helpful when you're analyzing two different events and you want to determine the relationship. You want to determine the outcome of those two events. So this is how we actually use linear models in the real world, because not everything forms an exact perfect straight line, but it does develop a correlation, which is just called meaning a relationship. So we have two main vocabulary words we have to talk about. First word is a scatter plot. You should have hopefully seen the word scatter plot before, but a scatter plot is a graph of ordered pairs that shows a relationship. Some form of relationship, whether the lines, it makes a line, whether they make a curve, whether they make a circle, it shows some kind of relationship. Now notice a scatter plot is a graph of ordered pairs. Your dots in a scatter plot are not connected. And I'll show you when we get down here in a second. And the last word which you heard me just mention was the word correlation. Correlation is the relationship between the data. So correlation is just a fancy word for relationship. So if I'm analyzing data, I want to be able to determine a scatter plot and a correlation. So let's look at this. It says, let's decide if studying longer will have affected your grade on Miss Mayfield's last spiral test. The table goes as follows. So notice on the left, these values on my left, these are the hours that they studied, and over on the right are the values of their test score. So whenever you have a table, your values on your left are always your X values, so I'm going to label this X, and the values on your right are always your Y values. So you can actually turn all of these into ordered pairs. Okay. So I now have to turn this into a scatter plot. So the first thing I have to do is I have to label my axes. So my x-axis runs along this. So I'm going to label that hours studied. Hours studied. And my y-axis, which runs along here, I'm going to label that as my test scores. So that's the most important thing. First thing you got to do is you got to label your axes. So obviously you're starting at 0, 0. So I first have to figure out how am I going to scale this side right there. So I got to figure out what I'm going to do. So I notice all of these values are increasing. They start at 1. My lowest value is 1, and my biggest value is 6. So I'm going to skip a line, and I'm going to label 1. And then I'm going to skip a line, and I'm going to label 2. Skip a line, 3. And the only reason why I'm skipping a line, there's no right or wrong way to do this. You just have to make sure it follows some form of pattern. And the reason why I'm skipping a line between each of these is to spread it out a little bit more. If I crammed them all in, it'd be super teeny tiny. So notice I focused on my lower value, which was 1, and my highest value, which was 6. So now I got to go and do the exact same thing with my y values. So I notice my lowest value is 40, and my highest value is 90. So I don't really want to start counting. I could probably count by tens, but that'd be pretty ridiculous because the first 4 I would not even need to use. So there's a symbol you can draw, which actually is a break in the graph to break the pattern. It looks kind of like a heartbeat. It looks like that. If I draw that again. Okay, it's just a little heartbeat. And that tells me it's a break in the graph. And I'm going to say, okay, I'm going to start at 40. And now I'm going to skip a line, and I'm going to count by tens. 50, skip a line 60, skip a line 70, skip a line 80, skip a line 90, and just to even skip a line, go to 100. Alright, so now I'm good to go and plot my first ordered pair. So I'm going to go 275. So I'm going to go over 2, and I'm going to go up 75. So 70, 75 would be right there. And I'm going to plot a point. So over 2, up 75, and I'm going to plot a point. And now I'm going to do the next one. I've graphed that one. Now let me do the next one. I'm going to go over 3, and I'm going to go up 80. Up 80, which is right there, and I'm going to plot a point. Graph that one. I'm now going to go over 5 and up to 90. Plot a point. I'm going to go over to 2 and up to 65. Plotted that one and that one. I'm going to go over to 1 and up to 50. Over to 1 and up to 40. And over to 6 and up to 80. Hopefully you figured out and you're okay with how I plotted all of those points. I just read my values from my table and I created my scatter plot. Now notice my scatter plot, I am not sitting here and I'm not connecting my lines. No, a scatter plot has a bunch of ordered pairs that show a relationship. So let's talk about this relationship. If you take a look at this graph, what do you notice? Hopefully you notice all of the values, they're starting to go up. As my x values get bigger, my y values get bigger. It's making some form of linear pattern. That's what it means when one increases and the other increases. So notice now, this doesn't form a perfectly straight line because obviously your hours studied and your test scores sometimes have a direct relationship. Sometimes you could have studied for 0 hours and ended up with a 100% because you're awesome. It doesn't happen all the time, but it could. But generally, what this data is telling me is that on average, the more hours I study, the better my test score. So if I wanted to write a conclusion, I would write over here, my conclusion, the more you study, the better your test scores are. That's my conclusion. Now, is this 100% accurate? Well, no. Obviously, there's lots of room of bias and human error, but generally, the longer you study, the better you perform. Just kind of as a self-standard, always. So, when I'm graphing data, I got to make sure I include 2 of the following things. This is huge. You might want to go ahead and highlight this. Be sure to label your axes. And what I mean by that is I labeled hours studied and then I went up there and I labeled test score. You got to label your axes in respect to what the problem is asking you. And the second thing, make sure the axes are scaled appropriately. When you scale your axes, these have to follow some form of pattern. You can't go 1, 5, 8, 9, 12, 15. It has to go in some pattern. If you want to skip a certain amount of values, you can do this little heartbeat symbol right here and then start lower so you can spread out your data. So now let's talk about, we have 3 different types of correlations. So I want you to go ahead and highlight the border of this box. We have a positive correlation, a negative correlation, and we have no correlation. So positive correlation tells me as my x values increase, so do the y values. Positive correlation, friends, it looks like a positive slope. Looks like a positive slope. So a positive correlation looks like it's forming a positive slope. A negative correlation looks like a negative slope. But what this tells me as x values increase, the y values decrease. This looks like a negative slope. And then we have no correlation, is that there are no pattern with the x and y values. So if there's no correlation, that means your picture looks like a blob. So a positive correlation looks like a positive slope. A negative correlation looks like a negative slope. No correlation means there is absolutely no relationship. It just looks like a blob, a bunch of random data. So it says, looking at a picture, I can determine what type of correlation a scatter plot has and how strong it is. Notice this word strong. You can determine if a scatter plot is strong or weak based on how your data values are clustered. If your data values are clustered close together, you're going to say that it's strong. If your data points are not scattered close together, but they still look like they're increasing, I'm going to say it's weak. So if I look at this first example, do my data, so even if you want to draw a line through it, looking at that data, what do you notice? You notice they're increasing. So this looks like a positive slope. So I'm going to say this is a positive correlation. And to say that it's strong versus weak, notice all of these data values, they're really pretty closely tight together. So I'm going to call this strong. If you come over and look at the next one, notice this one as well is also positive. These points and these points kind of mess it up, but if you were to take these points away and these points away, notice it would make a pretty positive correlation, so that's why I can say it's positive. So I'm going to say it's a positive correlation, but would you say it's strong or weak? Well, I'm going to say it's weak because my data values are not very close together. These ones are super far apart, and these ones are even further apart. So you know that it is making a weak correlation. Look at the next one. Would you say the next one's positive or negative or none? Well, I think it's negative because if I draw a line, it looks like a negative slope. Would you say it's strong or weak? Well, I'm going to say it's strong because my data values are close together. If you have a hard time knowing if it's going to be a positive, negative, or no correlation, sometimes covering up a couple of points might help you. If you look at this next one, draw a line to help me. If I covered up these points and these points, it looks like a negative correlation, so I'm going to say it's negative. And would I say it's strong or weak? I'm going to say it's weak. And if I come over and look at the next one, if you try to cover up, you can only cover up 4 points, no more than 4 points. So if I cover up those and I cover up those, if I draw a negative slope, does it look like it's going down? No. What if I draw a positive slope? Does it look like it's going up? No. So notice this looks like a blob, so I'm going to say this has no correlation. Look at the next one. Would you say it's positive, negative, or none? Hopefully you're going to tell me it's positive. Would you tell me it's strong or weak? I'm going to say strong because the data values are close together. So I want you to go ahead and pause this video, and I want you to answer those 3 questions on the bottom, and then we will go over this together. So now I want to talk about all this together. So if we take a look at this problem, it says we're going to create a scatter plot based on a student spends practicing their violin each week to their weekly % improvement. It says create a scatter plot. So, okay, I have practice hours and % improvement. Practice hours is on top, so you think that's X or Y? That's X. % improvement is Y. So the first thing I'm going to do is label my axes. Practice hours. And then I want you to come over on your y-axis and label % improvement. Alright, so I now have to start labeling my axes. There's no right or wrong answer. I obviously start at 0. So if I look at my x values, my lowest value is 6. My highest value is 18. So since they're all even numbers, I'm going to count by evens. And instead of starting at 2, I'm going to do my little heartbeat symbol, and I'm going to start at 6. And now I'm going to skip a line and count by 2s. 8, 10, 12, 14, 16, 18. And again, if you chose to label your axes some other way, that's fine. Just make sure you have some kind of pattern. So now I'm going to do my y values. My lowest value looks like it's 23, and my highest value looks like it's 58. So I'm going to draw another heartbeat going up my y-axis. I'm going to start at 20, and I'm going to count by 5s. 20, 25, and I'm not going to skip a line so I don't run out of room. 35, 40, 45, 60, 65, and I'm done. Alright, great. So now I'm going to go ahead and start plotting. So I'm going to go over 6 and up 23. So I'm going to go over 6, up 23. Now notice I don't have 23 exactly on my graph, so I'm just going to guesstimate and I'm going to plot it right there. So over 6, up 23, I'm going to plot that right there. I'm now going to go over 8 and up 26. So over 8 and up 26 again. I don't have 26 on my number line. I'm just going to plot it the best that I can. Over 8, up 26. Plot my point. I'm now going to go over 10 and up 35. So I'm going to go over 10 and up 35 and plot a point. I'm now going to go over 12 and up 30. Over 12 and up 30 and plot a point. I'm going to keep going. Over 14, up 46. Over 16, up 48. And you know what I just realized? I didn't count right here, people. It'd be helpful if I knew how to count, and now that doesn't want to erase. Let's see. This should have been 50, 55, this should have been 60, and this should have been 65. Can I erase these? Oh, I can. Alright, let me start again. So, I did those two. Over 10, up 35. Over 12, up 30. Over 14, up 46. Over 16, up 48. Over 18, up 58. So that's here. So hopefully your graph, when you plot it, looks something like mine. So, you have 3 questions that I want you to answer. What type of correlation is this? What would you tell me? You're going to hopefully tell me it's positive. Now you're going to tell me it's strong or it's weak. You're going to tell me? Strong. Because my data values are pretty close to forming a straight line. If you had to write a conclusion, what conclusion would you write? The more you practice, the better you perform. And last one. It says predict, so I'm making a guess. Predict the percent improvement if a student practices for 22 hours. So let's think about this. 22 hours, 1820, is somewhere right there. Would you agree? So if 22 hours was there, I'm going to go up on the y-axis. Where does that exist about on your y values? Am I going to have a point all the way down there? No. I'm going to follow my pattern. I'm going to keep going up, 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 up. So I'm going to be somewhere around here. So since I'm predicting, I'm just making a guess. So if it's somewhere around there, what would the value for number of hours be, or the percent improvement? It could be 65%. It could be 70%. It could be anything it could be 68%. It could be anything in this general region. You could even technically say it could be a little bit lower, but as long as it's forming a linear pattern, which it is, then we're good to go. So hopefully you are okay with this, and next class we will dive a little deeper.